Now we want to move on to actually calculating some probabilities. What we're going to look at is an example where we're dealing with a special, this should be a four-sided die, a special four-sided die, which instead of just having numbers on it, each side has a number and a letter. So what we're going to do, and this will make sense if you look ahead at the questions we're going to answer, we're going to make one table listing all of our possible outcomes related to the number that we roll, and another table related to all the possible outcomes for the letter that we roll. So the numbers that we have on our first die are 1, 2, 2, and 3. And on the second die we have 1, 2, 2, and 3. Looking at the letters on the first die, we have A, B, C, and C. And on the second die, we have A, B, and C. Again, what we're doing first is creating the sample space, all of the different possible outcomes. We're splitting up the numbers and the letters because that makes more sense with the problems that we're about to look at. Also, when we make our sample space for the numbers, I'm just going to look at setting up the totals because all the questions we're going to be asked are about the sum of the values showing. So in this case, my first cell would be 1 plus 1 would give me 2. 2 plus 1 would give me 3, 3, and then 4. Moving on to that next column, we would add the 1 from the first row and the 2 from that second column to get 3, 4, 4, and 5. Then we'd have 2 plus 1 is 3, 4, 4, and 5 again. And then we'd have 3 plus 1 is 4, 5, 5, and 6. For the letters, we're not combining anything. We can't add letters together. So we'll fill this out the way we did in the previous example. We'll take the A's from that first row and continue them all the way across. Do the same with the B's and then the C's in those last two rows. Then we'll look at each column and bring that first value down. So we'll add an A to each outcome here. An A to these outcomes again in the second column. Then a B. And then a C to each outcome in this last column. Now we can look at calculating these probabilities. In part A, we want to know what's the probability that we roll a sum that is less than 7. First thing we want to do is determine how many different outcomes there are. So if all we're interested in is the number, we have a grid of 4 by 4 answers. So 4 times 4 would be 16, or we could count those up. So we have 16 possible outcomes. And how many of those are a case where we roll a sum that's less than 7? In this case, all of those sums are less than 7, so we have 16 successes. So our probability will be 16 over 16, which is equal to 1, or 100%. We have a 100% chance that we will roll a sum less than 7, given these specific dice. In part B, what's the probability that we roll a sum that's larger than 6? There are no sums that are larger than 6, so again we have 16 possible outcomes. There are no successes, there are no cases where we could roll a 7 or larger. So this would be 0 over 16, which would give us 0 or 0%. Keep in mind we can never have a probability larger than our result in part A or smaller than our result in part B. Our number always has to end up being between 0 and 1. In part C, we want to know what's the probability that we roll a sum less than or equal to 3. So we still have those same 16 outcomes. Now what we want to do is count up the number of successes, the number of ways we can get a sum that's less than or equal to 3. So anywhere we roll a 2 or a 3, we have 1, 2, 3, 4, 5 cases where we roll a 2 or a 3. So our probability would be 5 over 16 or 0.3125. In part D, what's the probability that we roll a sum greater than 3? We still have our 16 outcomes. Now we want to count up all the cases where we get a value larger than 3, so 4, 5, or 6. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cases. No, 10 cases where that happens. No, I was right the first time. We've got 11 cases where we roll a 4, 5, or a 6. So we get a probability of 11 out of 16 or 0.6875. In E and F, now we have questions about the letters that are appearing. So we're going to consult that second table, that other sample space that we created. What's the probability that no B's are showing? So we still have 16 possible outcomes, and we want every case where there's no B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 cases where that's happening. So our probability will be 9 out of 16 or 0.5625. In part F, we want to find the probability that 2 of the same letter are showing. So we have 2 A's, 2 A's, 2 B's, 2 C's, and 2 C's, so 2 instances of 2 C's in that last column, which gives us 5 out of 16 successes for a probability of 0.3125. So again, in each case, what we're looking for is to take our number of successes, the number of times we can achieve whatever result we're interested in, divided by the total number of possible outcomes. And generating a sample space using a table is one of those methods to determine how many possible outcomes exist.